Alright, so inelastic collisions. So what are inelastic collisions? Inelastic collisions are collisions in which kinetic energy is not conserved. So say for example you have one ball here, this one approaches it with this one with velocity 0 at some VO. Well, these two, instead of bouncing off nicely, what's going to happen is that they're going to stick together, and then the end result is going to be a big ball moving at a smaller velocity. Now, what happened here? It's that in the joining of this, there was some heat or some deformation of the ball, and you lose some energy to the internal friction between it, or to the deformation, or to the heat, or to the sound. Kind of like when you hit a billiard ball, when you hit two billiard balls, it kind of makes a clack sound. It loses a little bit of energy. So usually in a realistic one ball hitting another ball, it's usually inelastic, but sometimes you could approximate it to being elastic. So say you have two balls, again, one approaching the other one, and then this is going to go into being one bigger ball going that way. So if this is VO and this V equals 0, you're going to end up with some V final in that direction. So what do you do? So you know that there's no outside forces acting on these, so you can go ahead and use conservation of momentum. So you have this M1, I'm going to name this M1, and M2, plus M2, and this is going to be 0, equals the momentum at the end, which is going to be big M, which is this giant thing, times your V final. Now what is big M? Big M is going to be these two things adding together and continuing on. So that's going to be something like M1 plus M2, intuitive, right? So then you're going to go ahead and substitute this for M1 plus M2 VF. And again, you could take this out and you end up with that. So your VF is going to equal your M1, your V initial, divided by M1 plus M2. Now, say it gets a little bit more complicated than this, and it goes into 2 dimensions. Example could be two balls approaching like that, and they collide here, and then you end up getting some bigger ball moving in that direction. So say you start off with 3 meters per second this way, and this weighs 2 kilograms, this weighs 3 kilograms, and this is 2 meters per second. And then the end result is going to be only in the x direction, which I'm going to denote x hat. And now the question is, what is this going to be? So I tell you there's going to be no y velocity. Therefore, your y velocity at the end must equal 0, right? So what does this mean? So go back to decomposing forces. Well, forces are vectors as well as velocity. And when you multiply m times the velocity, you get momentum. Well, that's still a vector. So you could still decompose this and have some rho in your y and some p in your x. Same thing happens with this, right? So now, you have that your y from 1 initial plus, note that these two are going to have opposite signs, y of 2 initial must equal what? 0. So then, from here, say this approaches some angle 30 and this approaches at an angle 60. Well, from here it's going to be sine, so 3 sine of 30, and now remember this is opposite sign, so minus 2, and it's going to be what? As well, sine of 60. Just make sure note that these, I kind of played around with the thetas, just make sure that you're using the right sine or cosines, depending on where they give you the thetas. This must equal 0. So then, we know that sine 30 is 1/2, so 3 over 2, minus 2, and this is going to be root 3 over 2, these two cancel out, equals 0. right? Therefore, I could say something like 3 over 2 minus root 3 equals 0, right? And this better cancel out. If not, then these two things are kind of off. Sorry, I kind of just made up those angles. But it should cancel out. You could just substitute this in with some v, and then it'll work out. Sorry about that. But yeah. Now the next thing you want to do, that should equal 0. Next thing you want to do is do your rows for your x's. Now, what is this going to look like? Just like that. Just that in this case, you're going to have 2 meters per second. In this case, you're going to have them both doing this and continuing on. So, this plus this row x of 2 must equal this final row in your x. Now this is going to be equal what? m1 v1, this all in your x direction, plus m2 v2, remember this is still initial, in your x direction, initial, must equal what? That final, which is going to be m1 plus m2 as we had discussed before, times your final velocity, I want to name it vfx. Now you have this, and again you just take the components and some other theta, doesn't matter, point is it's going to work out somehow. These thetas, you take the cosines and the sines of each, and you should end up with something at the end. So just using a theta so we get an answer. You could say that, again, this is going to be 3 over 2. Sorry, this is going to be cosine. So this time we're getting this, and this goes in that direction. It's going to be 3 cosine of 30, right? And then minus, plus, because this also goes in that direction, plus 2, again, it's still cosine of some angle, is going to equal your final, which is going to be m1 plus m2 times your v. And now, depending on what they give you here or here, whichever one they give you, that should be the answer, and that's how you figure out any type of two-dimensional inelastic collision.